All right, we're here to talk about the air planter system. Today we've got it installed on an FMS, which is a frame-mounted seeder. So we'll walk through an overview of the air planter package and what it involves. Air planter package allows bulk seed delivery for your singulated seeds. So on this unit we would put the singulated seeds up in tank number 1, and they would be delivered through the bulk fill system up to the meters. Our bulk fill system consists of a fan that's at the back of the unit. That fan supplies air pressure into our inductor that's below tank 1. So all of the bulk seed that you can place in tank 1 fills the inductor. The air comes through and carries it out to the diffusers. The diffusers are the black hoppers on top of our seed columns. So the seed comes down the column, fills up the singulation meter. Inside the singulation meter we have a plate that picks up seeds one at a time and delivers them to an extractor where they're carried out the meter, through the hose, down to the opener where a singulation tube places them in the furrow right ahead of the firming wheel on our PLR opener. Okay, so we'll go into some detail on the bulk fill system and all the components that make up bulk fill delivery. We'll start at the back here where we've got the fan. On this FMS unit we have a dedicated fan for bulk fill air. Some configurations will have the normal air seeder fan, and we'll split air off that to provide air into the inductor that's further up on the tank. Because this fan is dedicated to the bulk fill system, we have air that comes down this pipe, and under the air seeder the air is supplied into the inlet of the inductor, which is right in the center at the back. Then the air is split into 2 plenums on either side of the inductor, where it pressurizes the plenums and provides airflow through a screen and through the product to carry it out into the bulk fill hoses on the drill. So we'll have a closer look at that bulk fill inductor now. So we'll talk about, this is a cross section here of the inductor, kind of a cutaway. We don't have the inlet, which would normally be shown. The inlet comes in the middle, supplies 2 plenums on either side, so these both would have pressurized air in the round portions here. The pressurized air would pass through a screen which has been removed for this cutaway, but the screen would allow air to pass through here, and the soybeans that we saw fill up the inductor on the machine, they would be filling this area that's shaded in white. So if you can imagine soybeans or corn or sunflowers would be filling the bottom portion here. These plenums are full of air passing through a screen. The air is represented by these green lines, and the green lines, as they pass through the product, carry some of it out each side, and that's where we have our white hoses that complete the bulk fill delivery up to the front. So some of the principles that we need to understand here in order to properly set up and troubleshoot when we have bulk fill problems, there is a pressure sensor on the drill, or on the X35, that's labeled pressure A. As I mentioned, that pressure A corresponds to the bulk fill pressure. The static pressure inside here, if it's higher, then you'll have more air passing through the screen. If it's lower, you obviously don't have as much. And there's a minimum air velocity required for the air passing through the product in order to pick it up and carry it out. So if we don't achieve the minimum air velocity through the seed, then we don't get any product flowing out. In order to fine-tune the air for a given static pressure, there's also a bypass rod that is right through these ports. We've removed it for this cutaway, but there is an image on the screen showing slotted holes cut into the bypass rod, and what that allows is, again, pressurized air from this plenum to go through the middle of the rod, and then it enters the top of the outlet through this opening, and that allows it to force the air that enters the exit through this path. The bypass air allows it to exit through the hose out to the singulation meter. So in your operator's manual you'll see static pressure settings and suggested bypass settings for each crop type, because it's important, depending on the amount of air paths through the product. The bypass setting, we need to make sure that we have the right amount of product coming up to the outlet and the right amount of bypass air carrying it out, so we don't run into plugging problems. 2 of the features here that we also show on this inductor are these removable walls. So we added these in order to give us the capability of singulating sunflowers. Most crops, including corn and soybeans, will use this solid wall, and you can see product would fill this area, again carried up through the outlet passage here, and the solid wall allows a nice smooth transition out the hose. Sunflowers, due to their light weight and also their low seeding rate, we needed to add in this feature which allows the sunflowers to kind of hover and dance in this region a little bit longer, and then they can get carried out by the bypass air. So this is the screen that we want installed. While we're doing sunflowers, this needs to be installed in the inductor. And this is the screen, or sorry, not a screen, but this is the solid wall that we want installed to do any other crop besides sunflowers. When they're not being used, these rest right up here, as you can see through the end of the inductor assembly. All right, so we'll talk about some of the consequences of changing your static pressure here in order to get different results in the bulk fill delivery. Let's say we were trying to bulk fill and we were getting too much product in the hoses and it keeps plugging on us. Say all of the hoses are plugging. If you increase the static pressure in here and don't change the bypass setting, by increasing this pressure we're going to get more air through here, which would also carry more product out, and it would also make your plugging problem worse. So typically with volumetric air seeding, when we think of plugging, we would increase our fan to try to clean out the lines, but with this inductor, if we increase our fan, we increase the static pressure, which carries more product out of the inductor. So we would need to actually increase the bypass setting in order to avoid plugging in that scenario. So if all the hoses were plugging, the first step is not to increase the fan, but it would be to increase the bypass setting by 1 notch, and hopefully that would improve the situation. It's just important that you've got to realize static pressure and bypass setting go hand in hand, and if you change one, it's going to affect the other one. So they should be changed at the same time, or at least realize that increasing static pressure without changing the bypass setting to change the amount of air that goes into the outlet could make your plugging problem worse. So if we're running into plugging problems in the hoses and having multiple hoses filling or plugging full of seed, part of the problem could be that the static pressure was slightly too high, which would be forcing too much air through the screen and picking it up through the seed pool and then out the hose. In order to troubleshoot that, the first step would probably be to increase the bypass setting by 1 notch, which would allow some more of the pressurized air in here to escape through the bypass into this port, and it would clear the line out. And at the same time as it lets more air into this outlet, it would be taking away the air that's going through the product. So we would end up with less product entering the outlet, and we'd end up with more air cleaning out the line. So anytime you're running into multiple plugged lines, your first step would be to increase bypass setting. We have a pretty good handle on the recommended static pressures that we should be operating at. So we know these plenums should be at a certain pressure, and that'll be listed in the operator's manual. If you can try to keep the static pressure fairly consistent, it makes troubleshooting a little bit easier because we can just use the bypass setting to try to fine tune. There are instances where we might want to change the static pressure a little bit more to get more product flow out there, but understanding the principle that this plenum is pressurized and the 2 paths for air are through the screen and through the bypass, that'll help you troubleshoot any bulk fill problems you have between the inductor and the diffuser hoppers above the meters. So because you can see how the seed comes from above the inductor through the slide gate into forming a seed pool down in the bottom here, and the air has to pass through, we have a bubbling action of air and seed as it passes through here. And one of the requirements of bulk fill is that we use fluency agent on the seed in order to create very little friction and binding in the seeds as they pass through here. And that fluency agent also helps when we get out to the diffuser hoppers and in the singulation meter. We have multiple places where the seeds are reacting with each other and passing by each other. So fluency agent is required with the Bourgault air planter system. So we've got our inductor set up below tank number 1 on this FMS. Right now we've got soybeans in the tank, and they're being held out of the inductor right now by this slide gate assembly. So one of the ways to separate volumetric seeding from singulation seeding is by this slide gate. Right now it's closed to keep all the soybeans in the tank, but in order to enable singulation, we need to fill the inductor with soybeans or corn or whatever product you're seeding with. So we're going to go ahead and open the slide gate, which should allow soybeans to fill the inductor. So now we have soybeans down here in the bottom of the inductor, and when we pressurize the bulk fill fan, they'll be carried out these hoses and to the front of the drill where they'll fill up the meters. So some other features of the inductor, we have a bypass setting on either side. So that controls how much air flows through the product and out the hoses versus how much air goes around the product to clean out the hoses. We'll talk about that in a second. The other setting or the other features of this inductor is that it has a clean out door on the bottom. So before we put seed in, we want to make sure that door has been cleaned out and is closed and latched. And that also allows clean out at the end of the day or the end of your field. When we want to run out of product, we can open that door to reclaim all the seed that we haven't used. So now that we understand our inductor and how we have pressurized air entering the inlet, being divided into 2 plenums, passing through the screens to pick up our seed and carry it out the hoses, we're going to look at the hose routing and look at some principles of good hose routing. So ideally we would have the hose level or horizontal across the whole drill as it goes out the inductor, through some of the frame members, and up to the diffuser hopper. In the center of this drill, we have an example where we have a droopy hose. So there are 4 hoses that are routed properly and one still has a droop in it. Those low spots or droops can be a problem because they can collect seed as the bulk fill hose is full of seed, filling the columns, and as the column flow shuts off, that droop is where seeds will collect and it may not start flowing again when the on-demand delivery requires it from the meter. So if at all possible, the takeaway here is to eliminate any droop during hose routing, and that should hopefully make your bulk fill delivery problem free. Right, so as the hose comes across the drill, it's horizontal and then it makes a curve here right at the plenum where the meters are. That hose curves up, goes through what we have as a Y splitter, and then it feeds 2 diffuser hoppers and the columns and the meters down below. So what we're looking for when the bulk fill hose comes in here, we're looking for the hose to be fully inserted into the Y splitter, and it's also important that both of these sides of the Y are fully inserted into the Y splitter on the top part. Similarly, at the diffuser hopper, we need them fully inserted here too. So we've got a cutaway of what that looks like. This is one of the areas you can run into problems if it's not installed properly. So if we have a Y splitter like this and you can see a ridge inside where the hose is inserted to, if it's not inserted all the way, it creates a ridge inside, and as the seed flows by and flow is cut off, seeds can get hung up on that ridge, and then the next time demand is required in that diffuser hopper, the seeds don't flow by that ridge and you get plugging. So it's common for us to see plugging at the top of either side or at the diffuser hopper, and the cause of that is hoses that aren't fully installed. So if you're ever running into troubleshooting, that's one spot to look at. Here's another couple examples of hose routing and Y splitters. So we always want to make sure these Y splitters are vertical when they're installed. You don't want to have them too far down where they would be horizontal. We want them up vertical, and it's okay if we have hoses that are different lengths going into the Y splitters when we have a pod of meters just like this. Ideally we have a setup where they're both the same length, but this is just fine too. All right, so these diffuser hoppers are kind of the key to the bulk fill system. In order to get air from the fan through the inductor and through these hoses, we need the air to escape somewhere. That's enabled by these caps, which can be set in a couple different positions. Right now you see the cap that floats. It is allowing air to fill this hopper. The air can escape out the top and seed will fill the column. That enables singulation down here in the singulation meter. So what that looks like inside, in that position, there's a screen in each one of these diffuser hoppers, and the screen allows air to pass through it while retaining the seed, and the seed falls down below. So I've got a diffuser hopper, the screen. When we install these, there is an arrow on the hopper right here. There's also an arrow on each tab here on the screen. Those arrows are lined up when we install it, and then the cap is placed on top, and the cap engages this rib in the screen through these slots. So when the cap is placed on, these two slots fit over top of that rib, and that allows us to turn the screen while it's installed. If we turn it to the left, we're in the position where the cap can float. And so I'll take the cap off and show what the screen is doing inside. So when this screen is installed, it is installed and then is turned part way to the right to seal it. And what that does, it blocks the inlet completely using this solid face. So this, when it's inside and rotated into the locked position, would be just like that. And you can see that the screen would actually block the air coming in from the inlet hose, therefore no product would be entering. So we talk about in the owner's manual and through different procedures to empty out the singulation meter, these screens have to be in the locked position, and that's what it's referring to. The other position would be rotated the opposite direction, and that exposes this side of the screen to the inlet. And you can tell, because there's a gap there, the air comes in, passes through this side of the screen, and would be exhausted out the cap, because the cap can float, but the seed would be directed down by gravity into the column and then the singulation meter. So what's important here is to realize that the screen is placed inside and then rotated to the right to lock it and to block airflow, and therefore no seed will enter. Or we can rotate it to the left, which exposes the screen to the inlet and lets air come in, bringing seed with it, and that's how we allow bulk fill to bring seeds into the column. All right, so we've talked about the cap being able to float, and that allows bulk fill air to come in and escape. There's reasons we also want it in the locked position. Some of the requirements for the locked position include storage. We recommend that you have this locked anytime you store it in the off season, or even if you're on a rain delay. It's important to lock these caps just to prevent any possible, the wind might be able to lift it up and bring rainwater in there. So there's reasons why we want to lock this for storage. For transport, it shouldn't be required. And the last reason to lock the cap, and probably the most important, is that in order to fill or to completely run out of singulation seed, we need to seal the bulk fill delivery. So in a seeding scenario, we're bulk filling, there's air and seed being carried into the hopper. The column is full of seed and it's being metered out by the singulation meter. At the end of the field, if you want to be completely out of product here or very close so that your clean out, the product that you catch during clean out is minimized, we would lock this cap, and again that would prevent the air and seed from entering, and then you continue seeding, and that would draw down the level of seed in this column until you have just a little bit in the seed pool right inside the meter. So depending on your crop, there is a chart in your operator's manual that tells you how much seed is going to be in this column. So using the X35 and the area remaining, you can lock these caps at precisely the right time, leaving yourself a bit of a buffer so you don't run out of seed. Lock the caps, seed down that seed that's in the column, and at the end of the field you should have very little product to catch during your clean out. So those are the reasons to close the cap, and obviously we keep it open during seeding. So because we have pressurized air in the meter and the pressurized bulk fill air is from a different system, they're buffered by all the seeds in these columns, and they're kept separate that way. It's also important that we follow a process anytime we turn those fans on. The bulk fill fan always has to be first. So on your X35 monitor, pressure A is listed first, that's bulk fill. Same thing when you turn your fans on, bulk fill has to be first. When we fill the seed columns using the bulk fill system, the seeds in this column will block out the meter pressure when they're turned on. So it's safe to turn on the meter only after we have these columns full of seed. Same thing goes in field if you stop to maybe check your depth, check your seeding performance. If you shut your fans off while you're doing that, when you get back to the cab, bulk fill first and then meter pressure. Otherwise the meter pressure will force seeds up this column depending on your crop, and we want to avoid that. So always make sure bulk fill fan is turned on before the metering fan. So the last couple points here for bulk fill hose routing is that when this wing is folded up for transport, these seed columns will be full of seed, and sometimes they can almost be upside down. So a couple of the principles we need to follow is to have the inlet pointed away from the wing hinge, or straight forward or straight backward, but you never want to have the inlet facing the wing hinge, because when it folds up, the seed will drain out of the column into the inlet and it'll fill the bulk fill hose. So any angle similar to these two where we're facing away from the wing hinge, which is right behind me, straight ahead, away, or backwards would be okay too. We can take a minute now and you can walk around the drill that you have in the shop beside you. Look at the inductor at the back. You can play with the bypass settings, see the clean out door at the bottom, the diffuser hoppers and the Y splitters, and you can play with the screens inside to see how they block flow and allow flow. Take a minute to familiarize with that.
So we've introduced the bulk fill system. Just to explain a few things on the meter here. The bulk fill line that comes from the inductor underneath the tank comes up into the splitter here. And then from the splitter, we're feeding into 2 diffusers into 2 meters. Pay close attention to the hose routings and how they're installed into the splitter as well as into the diffuser. It's very important that the hose be installed right up to the blue portion here and seated flush in there. If not, it'll create a spot for seeds to bridge up against. If you look at this hose that's installed here, you can see how it's kind of pulled out from the bottom, indicating that there might be a gap in here and could be a potential bridging issue for the bulk fill system. Looking above the splitter here, you can see the same thing on the 2 outlets here. And then coming into the diffuser on either end, you can see how the hose is installed into each. Pay attention to the rib features on the inlet here and how they're flush with the inlet, compared to this one here, which may not be installed correctly as the ribs are not parallel or flush with that inlet. So as seed comes up, it's split and goes into each one of these diffusers. The cap on top of the diffuser rotates a screen inside, as well as seals or locks and unseals and unlocks the cap. You can rotate it either direction. You're going to look for the double hash marks here to help line up so you can remove or install the cap. Rotating it clockwise, you're sealing it, which means the cap can't move freely and can't vent. You would do this if you're wanting to meter out the seed column, and you're going to unlock to allow air to escape through the diffuser, through the screen, through the cap, and allow bulk filling. To show you in a little bit more detail here, when I line up the hash marks to remove the cap, you'll see the screen inside of here. So the screen installs, there's 2 nubs on either end of the handle that I'm gripping here with an arrow. And if you look at the diffuser body here, the hopper, there are arrow marks on either side for you to line those up when you're installing it, to get it in the right orientation so that you can line up the hash marks and then rotate into either position. You don't want to leave it with the double hash marks lined up for operation. You want it in either a locked state or an unlocked state. So as you rotate the screen counterclockwise, you're in that free position, and counterclockwise is locked. And what's happening inside of the diffuser is the screen is rotating inside of here. Now when you go to lock it, you can see here, the screen portion is not where the inlet port is. So what you're doing is you're effectively sealing it off and allowing the meter to meter out whatever's in the seed column, blocking off that bulk fill. When it's rotated the other direction, that screen, the screen portion here is in line with that inlet, and it allows seed to flow in and air to escape out of the diffuser. So as the bulk fill system is delivering seed, it comes in through the diffuser, past the screen, and down into the seed column here. Inside the meter, it'll fill up the hopper portion, which I'll show you in a minute. But what you want to do when you're filling the system is you want to wait until that column is entirely full before engaging the air for the meter. Now, the column full creates enough resistance to separate the pressurized meter air from the bulk fill system, with the screen being that point where the two systems are shared. When that screen gets and that hopper up inside of here are full of seed, it creates resistance against that screen for the bulk fill system and slows down the air velocity and prevents it from delivering more seed. What you'll see in the line here is you'll see seeds kind of dancing or fluttering inside the hose, but they aren't being delivered into the system. But once you start metering and that seed starts to travel down the column, you will start to see it bulk fill again. So with the meter, you've got a pressurization, air pressurization line that comes in at the back side here. And inside the meter, I'm going to remove the cover here. You're just turning these knobs to unlock, and they'll pop out forward. And then you just turn it counterclockwise slightly, and you can remove the cover. There's storage located on the frame here for both the cover and the metering plate. Now the metering plate, you're just going to grab the grab ring here and the knob here, just rotate clockwise until you feel it click, and then you can slide the plate off. Okay, so as mentioned, we got the pressurization air line coming in at the back of the housing here. With the air inlet you can see in the housing in this location here, which allows that air to come into the meter. Seed coming through the seed column comes through the hopper at the bottom here. With the seed gate, the handle's located here for adjustment. All you do is you pull back slightly and you can rotate up and down to adjust. In the closed position here, you could use this for accessing the meter for maintenance or service, or if you're wanting to empty the column, you're just going to open it up. For each different crop, there's a different gate setting. So as seed comes into the meter here, with the metering plate installed, lock it in place here. You want to check around the plate here for any play. You don't want there to be any play around the metering plate, otherwise you may have seed leaking out past the plate. So it's important to adjust that plate pressure. So this plate, as an example, I can push around and there's movement against the housing, so I know it's loose. Another way to check is if you remove this retaining pin. If you can rotate this freely like so, that means it's not set tight enough. So what you're going to do is you're going to back it off. Sometimes it gets caught. What you can do is you can remove the singulator and just set it somewhere. It's a magnet attraction, so it'll stick anywhere that's metal. Reinstall the plate. You can loosen it off and then just free spin it until it contacts the housing and stops on its own. And then what you'll do is you'll tighten it about another quarter of a turn. And then you'll find the nearest cross hole that lines up with the slot in the motor shaft here, and you'll lock it in place. And then what you're going to do is you're going to check around again to make sure there's no play against the housing. So I would consider that adjusted. Now I'm going to loosen off the plate here. I'll reinstall the singulator. As mentioned, it's just a magnet attraction onto here. So with the metering plate installed, adjusting the plate pressure and setting the hub here, you can also have an instance where the plate is set too tight. Now, it can be hard to diagnose because when you press around the metering plate, there's no play and it seems like it's adjusted properly. But what happens is it creates so much friction in the meter that it's hard for the motor to spin the plate, and you'll get an error on the monitor showing an over torque for that specific row number. I guess that's something to point out too, is each one of these meters will have a row number identifier on it, which matches up with the monitor. So if you have issues, it'll identify on the monitor which row it is, and all you have to do is walk outside of your walk outside to your planter and look for that indicator. But anyways, what you're looking for on the monitor is a torque value of 250 to 400%. Anything higher than 400% may throw an over torque error, but within that 250 to 400 is the recommended range for the torque. But setting it by hand, if you set it by how I explained, should be within that operating range. Now, as seed enters this area in the bottom of the meter here, it forms what we call a seed pool in this area. And as air enters the meter, it escapes through the plate, and it creates a force to hold the seeds on each one of these holes or cells on the metering plate. And as the plate rotates, it carries those seeds around past the singulator. Now what the singulator does, as the plate is rotating and carrying seeds this direction, if you can imagine this being the other way, each one of these lobes on the singulator is displacing the seeds away, and it's removing multiples that might be held, or more than one seed held on each one of these cells on the metering plate. And as the plate continues to rotate past the singulator with a single seed on each cell, there's a seal in the cover here, this C-shaped seal, which when it's installed, you can see that same profile on the outside here. It starts at the bottom of the seed pool and comes up to about the 12 o'clock position here. And at that point, what that seal does is it cuts off the airflow through these holes on the metering plate and releases the seed. And as the seed is released, air coming into the meter escapes through this nozzle or an extractor and trains the seed or captures it and takes it out of the meter. And from there, air delivers the seed through this seed hose to the opener. Now, if there's debris in the seed or cracked, damaged seed, anything that can get lodged or stuck in these cells, it'll continue to go past the extractor, but you want to make sure that that cell is clean so that it can pick up another seed on the next revolution. This ejector is located in about this position here with the cover installed, and what it does is it extends through each one of these holes and pushes any lodged debris out so that it can pick up, clean it, and pick up another seed on the next revolution. Now the cover, it's important that it's installed in this orientation. You can try to install it backwards, and it may look like it will fit, but you can't install the knobs. It has to be installed in this orientation. And the cover has to be installed in order for the meter to operate. And these knobs have to be locked. It provides a seal for the cover. Now, as I mentioned, seeds are released through an extractor and they go through a seed sensor, and you can see a green LED here which gives an indication of the status of the sensor. If the light is yellow, that means it's in a not ready state. Typically when you start up your planter, it will show yellow, and after a few seconds it will turn to a green, meaning that it's ready. When that green light flashes, every time it shuts off, it is sensing a seed, and it sends that signal back through to the monitor. If the light is blinking red, that indicates that the sensor is either dirty or that there's a blocked hose, or the sensor is blocked. So there's typically two things to look for there. Using a brush. So if you're going to remove the cover, if you want to access the meter just to do any kind of inspection, you want to close your gate. And using a clean out bag, you'll install it on the hook at the front of the meter here, and the strap you will attach to the bolt. And then if you remove your plate, any seed that's in the bottom of the seed pool here will just fall into the bag. If you want to empty the entire column and switch to a different crop or just clean the seed out, you can open up the gate here. But if you're wanting to do any servicing, I recommend closing the gate, otherwise you will drain all the seed out of the seed column and have to re-prime the system, the bulk fill system. So anyway, now if that light is blinking red, you can inspect to see if there's any seed stuck inside of here. Sometimes it can be hard to tell. If you shake the hose, you may be able to hear some rattling of seeds inside, which could indicate that the hose is plugged. To remedy that, you'll just have to remove the hose, maybe from the opener and from the sensor, and remove the lodged seed. Or if it's not a block because of seed, it may be that the sensor is dirty, and if you use a brush and just run it in through the extractor here, the optical is located in about this position here, and if just wiping it clean, you can use some soapy water, mild soapy water, just to ensure that you clean the sensor dry before you use it again. So reinstall all the parts here. And just make sure after you're done servicing, if you're wanting to go plant again and you have seed in your column, just make sure you open that seed gate setting up to what you had previously. So after you finish taking apart your meter for servicing, whether it be sensor or to check something else out, just ensure that you're putting on that cover correctly. And when you're locking these knobs in place, you want to make sure that you turn them until they lock in place, like so. If you leave them partially unlocked, there's a chance that due to vibration they can unlock and pop out in the field, and that would prevent your cover from making a good seal against the housing. And then just make sure after you've installed the cover that you open up your seed gate setting to what you had previously. Otherwise, when you go back seeding, you'll get an error saying that this row is not metering anything. So as for servicing the meter, most of everything on the outside of the meter is non-serviceable. It's more the moving parts inside the meter. So I'm just going to take off the cover here and point out a few items. So the metering plate, the plate seal, and the ejector wheel are all wear items. What you're looking for on the ejector wheel is there's a series of pins that pass through each one of these holes. If those pins are gone or wearing, it may be time to replace. The seal here is a stationary part that rubs against the metering plate. So over time, the seal does wear. What you're going to be looking for is you're going to be looking for cracks, or if it's really thin at the edge of the seal. And that part's just replaced by pulling the seal out, installing a new one. The ejector wheel here to replace for different crops or replacing for a new part, you just depress the tabs here and then slide the wheel off. And then likewise to install the new one, you just have to snap it in place. The metering plate, it's also a moving part, and the housing is stationary, so you can start to see wear grooves around the outside of the metering plate. Something to look for, if the plate is severely deformed or wavy in this direction, it may be an indication to replace. You want that plate to be nice and flat. The singulator is also a wear part. The points on each one of these lobes here, after having seed and wear experienced at each one of these lobes, they can wear down, as well as where the singulator rides on the metering plate can wear and take the singulator out or in from the rows. And what you would see there is poor singulation performance on the monitor. As well, inside the housing, you want to inspect the extractor, ensuring that there's no deformities or wear on the inlet of the extractor. As for transport, when the wings are folded up for transport, the seed can move around inside the housing. Typically, we want all the seed to be in that seed pool, but it can move around inside the housing. So it's recommended to close the seed gate when you're folding up into transport, just so that it contains the amount of seed that's in the meter. Even if it moves around, at least that amount doesn't enlarge inside the meter. What can happen is if you left that seed gate open and the meter was rotated into a position where more seed can enter in the meter, it can fill the entire housing here, and it'll prevent the meter from performing well, and you'll see it on the monitor when you fold into field position and start planting again. But if you close that seed gate, it just controls the amount of seed that's in there. A lot of the features in the housing are designed so that the seed, when the meter falls back into this position, it'll all go back to the seed pool here. One thing to note is up inside the air inlet is a check valve that prevents the seed from flowing back through that pressurization line that comes into the meter. As far as storage, it's recommended to remove a lot of the parts from the meter just to prevent them from deforming. It's the metering plate is ideal to store in a vertical position, resting it on the center portion of the plate here, just so that the outside of the plate doesn't have any weight on it and doesn't deform. A good idea to remove singulators, remove ejector wheels, and also a good idea to install plugs in the extractor and also at the end of the singulation seed tube on the opener, just to prevent any debris from building up in the hose during the storage. So the meter's not 100% waterproof. You can still have instances where water can get into the meter. So it's recommended if you're storing the planter or if you know that there's a big rainfall coming, it'd be a good idea to drain all the seed out of the seed column and the meter prior to that event. It's also a good idea to allow your meters to completely dry. So running the metering fan and the bulk fill fan without any seed before going planting, just to ensure that there is no moisture buildup in any of the distribution systems. Moisture inside the meter will cause seed to stick and you'll see poor performance.
I'm here today to explain our new PLR row unit that was developed in conjunction with the air planter technology. The row unit is a new disc opener for Bourgault. It was necessary for some of the key elements that were required for the air planter technology. I'll just go through the elements of the row unit. There's the mount, a hydraulic cylinder which applies downforce. There's an upper and lower parallel arm which helps maintain the geometry as the opener goes up and down. There's a single point depth control. There's a floating scraper, a singulation tube which goes with the air planter, a firming wheel which firms seed as well as catches the seed that's delivered from the air planter boot. There's independent packing with an adjustable spring and gauge wheel or packer wheel that comes in either a V-packer or an offset shoulder packer wheel. So there are some features on here. We can adjust the scraper height for blade wear with this bolt. So that'll go up for a maximum of 1 3/4 blade wear. At the same time, you also have to adjust the packer wheel up and down with this bolt. And that too has 4 different settings that will go to 1 3/4. As you've seen, the depth control is quite simple. It has a pull knob that goes up and then you lock it into your depth. The graduations of the depth setting is 1/4 inch. Depending on your packer wheel, the initial setting is with the V-packer at setting number 2 is about at a 1/2 inch depth. On setting 1 with the offset shoulder is at about 1/2 inch depth. As I was saying, we can adjust the spring to deliver more or less packing pressure. The initial setting from factory is at the lowest setting, but if you think you need more packing, this is how you go about changing it. This will come with your drill, so will this. It goes over this bar and then places in there. For the first adjustment, notch is where it's at. We use this window. For the second, you use this one. For the third, you use that one. So we're going to go from the first to the second. So we'll go into here. You go underneath the spring, up and over, and then there it is. As mentioned before, the packer wheel, you can get a V-packer or an offset shoulder packer, which are mounted slightly different in this configuration. This offset is what we have found has worked the best. So basically with all the spacers on one side, 1/4 inch spacer on the other side, set at 3 degrees. So if you have issues with trench closing, you can play with the side-to-side setting as well as the angular setting. For the offset shoulder packer wheel, we as a rule will run it straight and run all but we leave 1/4 inch spacer on this side and all of the other ones on the other side. To adjust the toe in, basically loosen this nut. There's a bunch of notches in here and they're set at about 3 degrees. So you just move it over. So the gauge wheel comes in 2 configurations, a narrow and a wider one. The gauge wheel serves 2 functions. It sets the opener depth. Also, it maintains this, it acts as a soil control wheel. And I guess there is a third where it keeps the blade clean. Typical adjustments for the wheel is you want to set it so it just slightly engages the blade. And there are shims that you can take out or put in to adjust it side to side. We have an optional offset shoulder packer wheel that goes with this opener. This is a typical setup as far as side to side offset, and this wheel is typically run straight. However, if you have some issues with trench closing, there may be some benefits of angling it again to that 3 degree position. Some of the features that have been incorporated in this new design is the cylinder port locations have been both located towards the top of the cylinder. That helps with hose wear on stubble crops. So we talked about the floating scraper before. It is a spring-loaded scraper. It's actually a polyurethane spring. So the end of the bolt actually pushes up in the middle of that, which applies the load to the scraper and to deliver the scraping action. To adjust it, when you loosen the bolt, the end of the bolt comes off the spring, which takes away all of the preload and allows you to move this scraper up and down very easily. Also mention the single point depth control with a pull knob that adjusts it through the range. Once again, it's set at 1/4 inch increments. I also mentioned previously that as the blade wears, the firming wheel assembly, which has a rubber mounted suspension on it to enable the firming wheel to oscillate and contour. The singulation tube, when installed, is installed to this assembly as well, so it's a single bolt that you can move up to compensate for blade wear. The firming wheel is made out of a polyurethane material. which is quite flexible and is resistant to mud buildup. General maintenance on the opener, there are several grease points. There's one in the front of the upper arm, the back of the upper arm, in this pivot, in this pivot. There is no grease nipple on the hub. It's a maintenance-free hub. The packer wheel has a grease nipple. There is also a grease nipple on the other side of the unit that lubricates the shaft that goes over to the gauge wheel. Then there's also a grease on the packer wheel pivot.
All right, so we're going to talk about the hydraulic requirements for the air planter system. In addition to the hydraulics required for the normal volumetric operation of our seating unit, we have two extra circuits required for this air planter. There is a bulk fill fan, which provides the bulk fill air delivery, and there's also a metering pressure fan, which provides pressurized air to all of our singulation meters. Each of those fans is on its own circuit, so that's how we end up with two extra circuits required for the air planter system. Both of those fans require the red case drain to be hooked up anytime they're operating. And in addition to the two fans, any of the units that are configured with more than 12 rows, we require a hydraulic power pack to provide the electrical power for our meters. So the 12-row unit does not have a power pack, but anything over that does. And that power pack is plumbed in series from the bulk fill fan. So it's good to know that the hydraulics for the bulk fill circuit run through the bulk fill fan, and on the return side run through the power pack to provide electrical power through an alternator to our singulation meters. So anytime the power pack is running, the bulk fill circuit is running, or the metering fan is running, we need to make sure the case drain is hooked up, and that should be all the hydraulic consideration you need for the air planter package. The bulk fill fan is pressure A on the X35 monitor, and pressure B is the metering pressure fan. So as you're adjusting the hydraulic circuits inside the tractor cab, trying to hit the static pressures listed in the operator's manual, pressure A is bulk fill, pressure B is metering pressure. So those two pressures on the X35 should be all the feedback required to properly set the hydraulic circuits on the air planter package. So as we mentioned, there's a power pack assembly to provide the electrical power for any planter that is more than 12 rows. For our 12-row planter, we get the electrical power from the tractor. There's a harness hooked up to the tractor battery through a connection at the hitch, and then comes back to the SDB, or distribution box, which is shown on the screen here. From this distribution box, the power is split into the harnesses that go out to each of our singulation meters. So as mentioned, the power pack required for units above 12 row is mounted at the front of the air seater beside the metering pressure fan. This power pack has a low voltage disconnect, which could be useful to help troubleshoot electrical problems. This low voltage disconnect is installed to prevent dead batteries. It will cut out the circuit as soon as the voltage in the battery drops below 11.6 volts. This low voltage disconnect will disconnect the battery from the ECU and the rest of the unit, but will not disconnect from the alternator. So this should eliminate dead batteries if you ever store the unit without switching the disconnect switch that's on the power pack to the off position. The low voltage disconnect will automatically cut it out at 11.6 volts. There is also a 150 amp fuse inside the low voltage disconnect. After the low voltage disconnect has cut out, it requires 12 volts to reconnect. And the key or the power has to be cycled on or off and then back on. So again, the low voltage disconnect will cut out at 11.6 volts on the way down and requires 12 volts and a power cycle in order to reconnect during startup again. So it's important to know there's a switch on the power pack, and we need this switch to be in the off position anytime the air planter is not being used. So for storage, long-term storage, it must be switched off. It would be a good habit to switch this off even if you're leaving overnight. Although it's not required for short-term storage, it is suggested. It's also important to know this switch should not be turned to the off position if the alternator is running. That would damage the alternator, so do not switch to the off position if the alternator is engaged.
So we touched on the bulk fill system and the meter system. Now we're going to focus on the control system, what you might see in the tractor cab. So in the cab we have two monitors. We have a seeder monitor and a planter monitor, completely independent systems. One is controlling your volumetric seeding or your fertilizing on your seeder monitor. Everything set up for the seeder is done through the this particular X35. The two have no link to each other, so the planter monitor is responsible for setting up all of the air planter functions and control of the meters, as well as the monitoring of bulk fill pressure. So once we've set up our bulk fill and our meter on our seeder monitor, we're going to, in this case, we have a FMS unit here, bulk filling out of tank 1. We're just going to, rather than disabling that tank, we're going to leave it enabled so that we can utilize the low bin level sensor alarm in the event that that tank empties out, as well as you can monitor your theoretical weight for that tank. So we're just going to turn it off, set the rate to 0, and just have it there for monitoring purposes. And then on the planter monitor, kind of go over the different views that we're going to see on the operation of the planter here. So as I mentioned, they're totally separate systems. So on your coverage map, you have to set up a new job because, again, separate system, we're going to need a new job compared to the seeder. So all of your as applied planter performance is going to be done on your planter coverage screen, and when you're exporting your job report at the end of a field, that's going to be from this monitor, not how you regularly get that information from your seeder monitor. So different coverage map. Along with that, we have our section control window. So if you want to turn your planter sectional off, that has to be done through the planter monitor, which is separate from the seeder monitor. With the planter, we also have we'll call it the planter mini view here, planter controller. That is going to be how you're setting your rate, whether you're doing VR. If you're setting that rate through this mini view here, or if you're setting that rate directly on your planter rate here. So within the ISO, because this is an ISO-based planter, because the software is ISO-based, everything is done through your UT on this planter monitor. So you have to have your UT enabled before you'll see this show up on your UT screen, which is all your planter information here. So at the top section of this operating screen, we have what we call the data grid panels. So we can display 4 different pieces of information here, which you can change what's being displayed by holding until there's a red box around it and then tapping to display different pieces of information. So first thing we can show is your tractor forward speed. So that's generally just going to match your monitor speed, so we're not going to display that information at this time. Next, we can show our singulator pressure. Again, you can configure these to be all the same if you wanted to, but pressure A in the FMS unit here would be our bulk fill pressure. Again, pressure B is going to be our meter pressure in inches of water. We have our system voltage or your alternator voltage. your singulation quality, so your worst and your best performing rows, as well as your target population, what your planting population is set to. So to change that population, you're going to select that number and type in whichever population you want to be seeding at or planting at, which again, if this is not set up to be ECU, if you're actually getting that information or set that to auto here, that's where you're going to enter your rate, and it's going to pull that information onto the planter. So if this is set to auto, you change it here and it'll automatically populate there. If this is set to ECU, you can't, that's grayed out, and you set that information right here. And again, if you're doing VR, you would select VR there and it'd all be coming from your coverage map. The last data grid panel here that we can view is our spacing. So even though we're setting our rate to, in this case, 55,000 seeds per acre, that'll automatically calculate the target spacing, seed spacing, in-row seed spacing that you would see in the field. So you can't change that. That's just automatically calculated from your set rate. And that's dependent on your row spacing. So again, we're going to set this to system voltage. That's how I like to set up the data grid panels. It's all important information that we like to view. Next, we're going to go down to the lower portion here. We'll call that the bar graph area. So right now we're displaying an RPM bar graph. So at the bottom of the screen, we'll see it's a little bit faint, but working from left to right, we're going to be able to view the performance of row 0 to, in this case, 20 rows. So with the RPM bar graph, when these motors are operating, you'll see a bar graph come up and go to the set RPM, and then that can be seen on the left-hand side axis here, I guess. So to cycle, there's a few different bar graphs that we can view for these same 20 rows. To cycle those bar graphs, you can either press this button here to change, now we're viewing the singulation quality, or you can tap just the center of the page to switch between the different bar graphs. So on our spacing screen here, showing between 0 and 200%. If your target spacing, which we discussed before, is 10 inches, say, but you're seeing maybe 15 inches between those seeds, that target spacing is, or the actual spacing on this bar graph is going to go down, showing that you have a large gap between those seeds. And that's going to be calculated for every row across the unit, giving a live readout of what that spacing is. Next we have population, which is again using that singulation sensor data, and if your population, in this case the 100,000 seeds per acre is what our target is, if our population, if we're seeing a lot of doubles, our population is going to be above 100%, so your bar graphs you're going to see are going to be above 100. If you're getting a lot of misses, the actual population is going to be below 100. And all of these rows are averaged and displayed here as our actual rate. So 100,000 seeds per acre is our target. You can see individual rows performance on the bar graphs, and the average of all those rows is displayed as an actual population when you're in the field. So again, RPM, our singulation quality, so that's 0 to 100%. If you have, say, 2% doubles and 2% skips on a certain row, that bar graph is going to go down to 96% for a singulation quality. Depending on which row is performing poorly, that's the one that's going to dip down there. Likewise with spacing quality. And yeah, population, I guess, is the most common bar graph that you'd want to be viewing. Seems to be the most valuable information. That's what you're targeting. That's what your actual is. Which rows are performing the best. Within the bar graph screen here, we have this TCSC. So that's your task controller indicator. So the X35 is a task controller that's controlling the planter ECU on the drill. So this task controller, we want that to be on at all times while we're operating. Without that on, you will not get section control to work properly or work at all. Your rows will continue to spin. Also within the bar graph area, we have the lift state of the openers, or the opener state, whether it's in the up position or down position. So I mentioned the planter and the seeder monitor are completely independent consoles, not linked at all. There is one way that we have them linked through harnessing to record the state of the openers. So what that allows us to do is have a single master switch on the seeder monitor that we can use to also turn on your planter at your headlands, or if you wanted to raise your openers and stop planting. Rather than having to hit two master switches, we have them linked with the opener state. So when the openers are in the up position, you will see that triangle flip to the up position, signifying the openers are up. When you lower your openers, that's going to switch to the down position. So we've covered the bar graphs and the indicators. Next we'll go on to the right-hand side buttons, we'll call them. Here at the top we have our rows off. So what that does is, starting from the left-hand side of the machine, you can turn each individual row off. And this button turns them off from the right-hand side of the screen. And you can see the indicator, the row indicator here is changing to red, signifying that these are turned off. If we hit the row on buttons, similarly it'll turn each row on from the center line of the drill, working our way outward. So that might be useful if you wanted to narrow in on a specific meter to control. The next button here on the right-hand side of the screen is our nudge buttons for your rate. So hitting the plus, we'll see that rate bump up. In this case, it's set for 5,000 seeds per acre. If you wanted to bump your rate up through those buttons, you could do that, or back it off. Or again, type it in to whatever rate you're trying to target. Towards the bottom here, we have a prime button. So what that button does is it rotates your meter after you've engaged your pressurization fan. That'll rotate the meter 3/4 of a turn to prime each of the singulation meters with a seed. So a single press of that button will rotate the meters 3/4 of a turn when your meter fan is on, so that it's ready to engage the headland and not have to worry about a gap in your field due to the meters turning without having a seed on the plate. I mentioned this button used for cycling your bar graph screens. We also have the cycle screens button here. This is our main operating page. If you press that, we'll get to our total screen. Here we can see our totals for our job, our lifetime totals for the machine, as well as individual planter performance if you were diagnosing a row. Again, you can see the torque percentage here, which is useful when you're setting your meter pressure plate. You can view that to ensure you have that plate pressure set correctly by each row. As well as you can see seed count data for each row individually. Press that cycle screens button again, we'll get to our settings page. Because we have put soybean plates into the meters when we were setting it up, we also have to set it up on the monitor. So if we go into planter, we can then select products, and we can see that we have soybeans selected. It's highlighted here, and we can see that our soybean plate has 100 holes on the disc. So we want to ensure that that product is set up properly on our monitor as well. So here we previously made this product soys in this case, and the seeds per rev is the important one. Again, 100 holes on this plate. We want to enter that here, and what that does is allows the monitor to automatically calculate the RPM of each of the motors to spin at the correct RPM to get your correct rate. So that's the important one there, is to make sure your product is set up properly. If we go back to our settings menu, this run motors is also something that's helpful. You can enable certain rows if you want to check performance of one individual row. You can enable a certain motor at a set speed, maybe it's 5 miles an hour at whichever rate you want it to be at, and you can run that particular row. So I'll just disable that. Go back. The status is an important one here. You can we can view our alternator voltage on the main screen. This is just where you set your warning. Similarly, you can set your singulation, low warning pressures for alarming an operator of an incorrect pressure, but also this health thresholds. You can set alarms. In this case, we just have them turned off, but this no seed alarm is an important one. That tells you if you have no seed going down your meter in the event of a plug or a meter that's out of seed. So we'll just leave that disabled for right now, but normally you'd want to enable that one when you're operating in the field. And then, yeah, we'll go back to the main operation screen here and go through the process of inducting product into each of the meters and then turning them on and verifying that everything is working properly on the bar graphs, or displaying that information on the bar graph and making sure that everything's working properly.
All right, so we'll start filling the bulk fill system here. We've got pressure A is the bulk fill pressure, pressure B is the metering system. And if you recall, we need to start bulk fill is the first step in filling the system. So as we rev up as we increase the hydraulic flow to the bulk fill circuit, we'll see the pressure in the inductor increasing. We'll just keep increasing the flow here until our target for soybeans is 18 inches of water. So we'll keep going higher and higher until we get close to 18. Okay, then here we can see some product starting to come into the seed columns. Coming up the bulk fill hose and entering the seed columns, we're starting to see an accumulation of soybeans. If you'll notice, the soybeans are continuing to rise in the column. And if we come up here and close off the cap, like we've talked about in the past, if we lock that cap, the flow of soybeans stops. And because each of these 2 meters share a bulk fill hose, it goes into the Y splitter and splits some product into 8 and some into 7. We can start to see product coming into 7 now that we've blocked off number 8. So we see soybeans starting to accumulate in the bottom. So that was just for demonstration purposes, but we can open this cap back up again. And we'll notice number 8 starting to fill. So that's an example of locking the cap and how it prevents bulk fill seed from coming back into the column. Okay, so we have a full column here on row number 8. And row number 7 is just filling up. So this is what we see when it's the initial fill. Remembering we've got to have the metering pressure off in order to get the bulk fill system to fill. So we've got most of the columns full. Just talk louder? Okay. So we've got most of the columns full on the air, across the air planter. But we've got a pair of rows, number 5 and 6, that we have no seed into. So what we've got is a plugged bulk fill hose on the drill. A couple things you can do to help with that. You can shake the hose a little bit to try to dislodge the collection of seeds. And if that doesn't work, you can travel further back and try to find where the jam is. Shaking it will usually dislodge any bridging. If that still doesn't work, you can take off the clamp and try to dump the seeds out of the hose. Okay, so we've got columns number 3 and 4 here. They're completely full. There's a little bit of air still coming out of the cap, but because the seed has made it all the way up to the screen that's in the diffuser, it has slowed the amount of product coming in there. And we can see there's a little bit of product here just kind of floating or hovering inside the hose. That's pretty normal when the seed columns are full, and it won't start to flow again until we meter out some of the seed and make room for more seed at the top. We've got the bulk fill pressure. Our target is 18 inches of water column. We engage the meter pressure fan. Okay. Once we get some pressure in the metering system, we can press the prime button. So here you can see the meters all turn green for 3/4 of a revolution. We'll rotate to the RPM screen, and that'll show us if we hit the prime button again, we'll be able to see the RPM of every meter for that 3/4 of a turn. So we should have seeds stuck to all the holes on the plates, and now we'll be able to get the meter pressure dialed in. 15 is the target for the meter pressure with soybeans, and again 18 is what our target is for the bulk fill. Okay, so we've got our meter pressure as pressure B, and that's set very close to 15. Our bulk fill pressure is fairly close to 18. So we're going to go ahead and run the meters, and we'll see population performance. We'll set the rate. We'll set it for a lower rate. All right, so we have a simulated GPS speed of 5 miles per hour, which is required before we can engage the meters. We've got a green master here. Once this planter master switch is turned on, you can see our opener state is down. So the population screen shows us that we're getting metering from all the rows. When you see a low bar graph like we have here on row number 8 and also row number 16, that's your indication that there could be something going on with that meter. So we'll stop it and have a look. Okay, so we saw on the screen row number 8 wasn't performing very well. When we come to look, we can see the LED indication light on the seed sensor is blinking red. And a red blinking light indicates either a plugged row or a dirty seed sensor. So we can, first we'll set the seed gate to 0, which will prevent this seed column from emptying when we take the cover off. We'll grab a clean out bag. Okay, so we'll take the cover off. That bag will catch all the seed from the seed pool. We can see the extractor is full of seeds here, so there's definitely a plugged row. And upon further inspection, we have, during the install, there's a kinked hose near the opener. And if there's no air carrying the seeds out, obviously we end up with a plugged hose here. So we'll get that cleaned up and we should have good meter performance again from row number 8.
So we had demonstrated a little earlier about priming the bulk fill system and having a plugged hose and how it wouldn't fill the seed columns. But if you had bulk fill issues in field where you had a plugged hose or you had one of the branches from the splitter here bridging inside the diffuser and preventing seed from filling the column, what can happen is the seed column, after it meters down, you don't have enough resistance to separate the metering pressure from the bulk fill pressure, and so you'll start to see the seed column fluidize and start to move up and down. And we'll demonstrate that here to show you what that looks like, and that's typically indicative of a bulk fill issue, not metering. So we'll start up our fans and show you. Okay, so we just started metering here, and you'll start to see the seed column moving down, which it does during typical bulk filling. But when you start to see a gap at the top here, just watch for when that gap grows and you'll see the seed column start to fluidize. So the bit that's floating in the top of the column here is just shells from the seed. Those aren't seeds themselves. The fluidizing that you're starting to see now is these ripple effects that are coming up through the column. And eventually it'll get to a point where the pressure in the meter will hold the seed column and prevent it from dropping down into the meter. So after the seed that's in the meter has been metered out, you'll start to see no seed being metered out. This is the fluidizing that we're talking about. This is a bulk fill issue. If you intended to meter out the seed that's in here, you would simply lock the diffuser. And now you can see that you've sealed off the bulk fill from the meter, and that allows the seed to meter out. Whereas compared to number 3 here, you can see the seed is being held up and fluidized down here. Once this seed meters out, this meter will not meter any more seed. So in this scenario, we've unplugged the bulk fill system, but we still have meter in the column. Here you can't start the pressure for the meter and the bulk fill at the same time. You have to start the bulk fill first and wait for all the columns to fill before starting the meter again. So as you can see, we're starting to bulk fill again. But like I said, you have to wait until that seed column is full before engaging the meter pressure and starting planting again. It's not uncommon for the bulk fill system to fill up one column before the other. It's all on air resistance. So if you have a shorter hose and a longer hose, it'll typically fill the one that has the shorter hose first, but rest assured it will fill both. You'll notice after this hopper becomes full, it'll start to fill this one. Now you can see that there's no more seed being drawn up through the bulk fill system. You can now engage your meter pressure and your bulk fill and continue planting.